Hi everyone. In this video, I would like to share some ideas of using the Desmos Graphing Calculator for explaining the linear inequality in two unknowns. So here we start with a blank graph paper in Desmos, right? And you can go to the Desmos calculator in this website. And let's try, let's say 2x plus y minus 3 equals 0, and then you will get a line, okay? And actually, if you click on the line, you can also see any points here on the line. And similarly, we can also type 2x plus y minus 3 greater than 0, and you will see a region, okay? So you may actually ask the student to guess why a region is being shown, right, when you type in inequality. Even they have no ideas of what inequality in two unknowns is. Right. Now we can further explain what it means. Here we try to hide the region first and then concentrate on the line. Okay, if you track here on the line, then you can see some points anywhere on the line. And one quick demonstration would be like this. Maybe you can try to, let's say, I drag some here. Okay, so this is a point on the line, just an arbitrary point. Okay. But if you imagine that I'm going up, okay, from this point, and so the x coordinate will not be changed, but the y coordinate will be increased, okay? And then if you go back to this expression, 2x plus y minus 3, okay, instead of equal to 0, then it will be bigger than 0, right, when you go up. And similarly, if you go down, okay, the y, for the same point, the y coordinates will decrease while the x coordinates will not change, all right? And what happened to the expressions there? 2x plus y minus 3 will be smaller than 0. All right, so this is one way of describing how you can see the region, right, above. That means for starting from any point on the line, imagine what happened when you go up or go down, okay? Now, similarly, I can also choose another point. Now, this time I can also talk about what happens when the point, okay, move to the right or move to the left. Now, at this particular point of the line, okay, we know that 2x plus y minus 3 equal to 0. And if you go to the right, right, then the x coordinates will increase, while the y coordinate will be unchanged, okay? And so if you look at the same expression, 2x plus y minus 3, then it will be greater than 0, okay? And similarly, if you move to the left instead, okay, then x coordinates will decrease, right? And therefore, that's why you expect the expression 2x plus y minus 3 become smaller than 0, okay? So that is a quick demonstration. Now, what I'd like to continue will be some other illustration that we can do in the Desmos Graphing Calculator environment, okay? Here, I would like to add a point, AB, okay? And if you press enter, so AB will be a point that is movable on the screen. And then you can also see the individual values of A and B being changed, or you can also drag the point A or drag the value of A or B independently, okay? And then you can see how the point may be moving around. And let's say if I put it somewhere, okay, on the line, something like this, right? Somewhere around here, okay? And it may be, okay, a point on the line, and it will be satisfying the equations, right? Making 2x plus y minus 3 equals 0. Okay, now let's check this value. If A and B is in a substitute into the left side of the equation, okay, it will be 2a plus b minus 3. And okay, when we press enter, and you can see the value, it is equal to 0, right? If you are putting it accurately on the line. And of course, if you move it now to the right or move it up, okay, then you will see that the value is changed and it will be greater than 0, right? And if you move it down the line, then this value will be negative, right? So you can see the effect, something like this. Okay, if you want to, let's say, because it's not easy to control, okay, very carefully the point A and the values of A and B, but you can change the slider and make it move from negative 10 to 10 instead of 0.1. Okay. And similarly for the B, you can also adjust the step. Okay. Right. So in this way, then you can easily move the point, okay, more accurately on the grid, right? And now, if I move the point B or increase it, then it will just move up, right? So without changing the balance of A. So this is one way that you can have more control on the movement of the point, right? Okay, now another way you can demonstrate the value is like this. You can use the label here at the point. You can click on the label box, and you can see the values of the point 1, 3 is by default is shown. Okay, and you can change the label to be anything you like. Okay, for example, it can be instead of showing the coordinates of the point, which is also very useful. If you move around, then you can see more clearly of the point. But I would like to know what happened when the point is substituted into this expression, 2x plus y minus 3. So the label can be something like this. Okay, 2a plus b minus 3. Okay, so now I change the label, 2a plus b minus. Of course, you can't see the actual change of the value, right? So maybe you can use the dynamic label. So in this case, we want the values of A. So the symbols will be like this, okay? So you can see this now, I replace the things in brackets by the values of A. And similarly, I can replace the values in the brackets by the value of B, okay? So you can see this should show you the result when the x and y coordinates of the green point is substituted into the left side, right, of these expressions. And how do you know whether this is greater than or smaller than 0? Yes, you can modify the expressions below. Maybe I can call this expression M. And so the label of this point can also be, let's say, yes. Okay, the values of M. So now you can see that this value is equal to 10, right, which is greater than 0. But if you put it back to somewhere on the line, then it will be equal to 0. Okay, and so this can easily show you the values of the expressions. Maybe you also want to show the values of the point on the screen at the same time for just easy reference. And here I will add another point. Same point AB, okay? But now I can show the coordinate at the same time, okay? Using just the same point. In fact, it is just the same point, right? But I duplicate it. So actually you can hide the point, okay? But the label is remained, okay? If you want to adjust the positions of the label, then you can click on these circles, hold it, and then you can see the choices. So you can move it down, okay? Similarly, for the one above, if you hold it, then you can put expressions above the point, okay? And now you have one point, but both showing the coordinates of the point and the results of substituting the coordinates into the expressions, right? So this can also be shown, right? And if you don't want to show many of these values, then you can also add the folder. Okay, so put all these values under the folder. You can see a straight line here, indicating that it is now under the folder. And similarly, this point may not be needed. Okay, and maybe the A and B depends on whether you need it or not. Okay, so you can now click this triangle to hide the folder. Right, so now you can see more clearly only the equation of straight line, the region, and also the point, the movable point on the screen. Okay, so that may give a better demonstrations of how the values on the left of this expressions, I mean the expressions on the left of this equation change, okay? Whether it's equal to 0 or greater than 0 or smaller than 0, right? When you move the point around on the plane. Okay, so maybe you can have a try. By the way, when you want to find the syntax for the labels, you can go to the help center of Desmos and find out something about the labels, okay, including other things you can do with the label. And then down below, you can see the options of dynamic labels, which I just used to demonstrate, okay, how I can show the value, the actual values of some expressions while you're moving the objects on the screen. Okay, that's all for my demonstration.